In this video, we're going to be talking about MotionMagic, which is essentially Falcon's or TalonFX's way of precise precisional control. So first, we're going to start off with just some conceptual ideas and how MotionMagic works, and then then I'll walk through a code integration of MotionMagic, and then we'll talk about testing. So, like PID and feed forward, I've got a few conceptual ideas to go over. So let's get started. So just a quick overview of what I'm talking about within these Google Slides. We'll just talk about what MotionMagic is, how it works, and some of the benefits of MotionMagic, because of course we've talked about two other um, control schemes, so I want to hone in on why this one is a little bit better. So MotionMagic is a TalonFX specific control mode, so it's used with Falcons, that allows you to set a specific target, or remember, set point from your vocabulary from PID, by generating a trapezoidal velocity profile. So I'll talk more about what that is in a second, but it's primarily used for mechanisms such as elevators and arms. And the key part is that MotionMagic is a positional control thing. Doesn't really have to do with controlling the velocity, it's usually about positional control. So we primarily use it for elevators and arms because it allows you to very easily move from one position to another and hold your desired position. So here's a quick visual on how it works. So some of the behind the scenes on the velocity, position, acceleration as you use MotionMagic. So the key part about MotionMagic is that you set the desired velocity and acceleration. All right. And you also set the P, I, D, and F values. Now, the feed forward value is a separate constant that we really haven't talked about yet. So all it really is just it's just a feed forward constant that you set. So it's like any other PID parameter, essentially, at least the way Falcon treats it. So again, more tuning will be required, but we'll talk about that later. Um, so now, essentially, we've got a combination of PID and feed forward. So let's just talk about this graph for a second. So the reason why it's called trapezoidal motion is because the velocity, or rather the graph of velocity, forms a trapezoid. So all it's doing is it's ramping up the velocity. It's going to run it at a constant velocity for as long as it can. Again, it's the desired velocity that you set. And again, we're looking at the graph in blue. And the velocity will then ramp down as the position gets, as close to the desired position as you specify. And notice that the shape of the position curve looks pretty similar to the graph of position that I showed you from the PID slides. So something interesting to note. Yeah, let's move on. So some of the benefits of MotionMagic are that you can maintain control of your mechanism for the entire duration of motion. So again, we're not concerned about getting to some end goal as fast as possible, kind of like PID. Notice, we are in full control of the velocity, which means that we have smooth control over our entire mechanism. That's why MotionMagic is powerful. So another thing that you can do, and actually what we do this year, at least in 2023 with our robot, is that we set an arbitrary feed forward, which can actually take into account the inertia of your mechanism at different set points. So depending on where your arm or elevator is, you can set a different feed forward. We're not going to talk about this because that's a very specific use case scenario. For now, we're just going to focus on some of the basics of MotionMagic. And again, setup and tuning is pretty simple. It's actually very, very similar to PID. So let's get started. So the first thing that I want to do is get rid of some of the stuff that we did with the simple motor feed forward. So delete that, delete that. Why are we freaking out? We shouldn't have to freak. Oh, are we missing a brace? Nope. Let's see. What's this error? That's okay. Huh. That's weird. No, I don't want to delete periodic. That's what's fine to me. What is going on? Okay, that was weird. Not sure what happened there, but we look to be good. Okay, so the first thing that we're gonna do is set up our PID and F values. And for now, what I would recommend is setting just the P to 0.1 and then the IND to 0, and then set your F to something small like 0.01, and then you can adjust as necessary. So elevator motor dot config JP. Again, slot ID is 0 and value 0.1. And actually, I'll just copy and paste for this just to proceed along. 0 at 0. Config, and we're going to config the feed forward constant, which I'll just set now as 0.01, something small. Okay, the next thing we're going to do is configure the velocity and acceleration. So again, we specify the velocity and acceleration parameters for MotionMagic. So what we're going to do is elevator motor dot config motion cruise velocity. So again, this takes in the weird TalonFX ticks per 100 milliseconds. So what I would recommend to start off with, and a safe value, is 10,000. It's a pretty small value relative to the Falcon, and you should move pretty slowly, and it's just a good way to start testing. And then next thing we'll do is config motion acceleration. And this I would set something like 5,000, roughly half, just for the testing phase. And then you can start to mess with these values, speed them up as needed. Now, all you need to do is public void, we'll call this set elevator position. Taking a set point. And all it is elevator motor dot set, and the control mode is now going to be MotionMagic. And all we have to pass in is a set point. And there we go. So one thing that I want to talk about is that in the shooter subsystem, remember, we had to do this weird unit conversion, right, to get it to work with the native units of the Falcon, because with the shooter, we work with, RPM, friendly human units. The Falcon, on the other hand, does not. So one thing that you need to keep in mind is that the value that you pass in needs to be Falcon friendly. So what you need to do is figure out the gear ratios that you are working with your subsystem. So that's something you're going to have to look into, and you're also going to have to look into whether it's gearing up or gearing down, or uh, and based on that, you need to see if you have to actually multiply or divide your set point values. So that's something else to keep in mind. You can always reference our 2023 code inside our constants file, where the constants.java file, where we have a bunch of different unit conversions happening. So if for 2023, for context, we work with an arm, and the arm has different radial positions. So we have a bunch of different conversions going from native units to radians, etc. So in the case of elevator position, honestly, it might not be super important for an elevator because you can sort of just read the encoder. So one thing that you can do actually to figure out the current elevator position is just do public double get elevator position. I believe this is a get selected sensor position. And what you can do, oh, sorry, forgot how to return. And what you can do in code is read the elevator position, see where it is, and then adjust your set point as necessary. So for an elevator, honestly, it might not be super crucial. You could work with Falcon units by default and just make your set points based on whatever the reading of the selected center position is. So you could do something like smart dashboard.put number, and we'll call it current elevator position, and it's going to autofill it, but you call get elevator position, and then in smart dashboard you could read what the current elevator position is, and then adjust your set points as necessary. So that's something else you can do. But if you really are concerned about working with units that are human friendly, then look into the gear ratios of your components and figure out whether or not you need to do that multiplication or division based on whether or not it's a gear up or a gear reduction. So that's something for you to look into. Now, one thing I will have you do sort of on your own once we conclude this video is go ahead and write a command. So write a command that sets the elevator position and bind it to a button. You should already be pretty familiar with how to do that. So go ahead and give it a try. So that about wraps up our Motion Magic video and some of its basic uses, and we'll catch you in the next video.